This concept of weights for edges is an attribute that makes GNNs so powerful. They allow us to take into account both structural, dependent, and singular, independent, information. For real-world applications, this means we can consider external as well as internal information. Degree matrix, D. The degree matrix of a graph can be found by using the concept of degrees covered earlier. D is essentially a diagonal matrix, where each value of the diagonal is the degree of its corresponding node. Notice that the degree is simply the sum of each row of the adjacency matrix. These degrees are then placed on the diagonal of the matrix, the line of symmetry for the adjacency matrix. This leads nicely to the final matrix. Laplacian matrix, L. The Laplacian matrix of a graph is the result of subtracting the adjacency matrix from the degree matrix. Each value in the degree matrix is subtracted by its respective value in the adjacency matrix as such. There exist other graph matrix representations like the incidence matrix, but the vast majority of GNN applications on graph-type data utilize one, two, or all three of these matrices. This is because they, and the Laplacian matrix in particular, provide substantial information about the entities, an element with attributes, and relations, a connection between entities. The only thing missing is the rule, a function that maps entities to other entities by relations. This is where neural networks come in handy. Euler paths and circuits. A Euler path starts and ends at different vertices. A Euler circuit starts and ends at the same vertex. What is the difference between a path and a circuit? A path is a sequence of vertices with the property that each vertex in the sequence is adjacent to the vertex next to it. A path that does not repeat vertices is called a simple path. A path is a sequence of vertices with the property that each vertex in the sequence is adjacent to the vertex next to it. A path that does not repeat vertices is called a simple path. How do you know if a graph has an Euler circuit? A graph has an Euler circuit if and only if the degree of every vertex is even. A graph has an Euler path if and only if there are at most two vertices with odd degree. How do you find the Eulerian path?